Introduction. Cognitive radio, CR, carries bright prospects for very efficient utilization of spectrum in future. Since cognitive radio is still in its early days, many of its theoretical limits are yet to be explored. In particular, determination of its maximum information rates for the most general case is still an open problem. Till today, many cognitive channel models have been presented. Either achievable or maximum bit rates have been evaluated for each of these. This lecture will summarize all the existing results, makes a comparison between different channel models and draw useful conclusions. The scarcity of the radio frequency, RF, spectrum along with its severe underutilization, as suggested by various government bodies like the Federal Communications Commission, FCC, in USA and Ofcom in UK like RAFE, and has triggered immense research activity on the concept of CR all over the world. Of the many facets that need to be dealt with, the information theoretic modeling of CR is of core importance, as it helps predict the fundamental limit of its maximum reliable data transmission. The information theoretic model proposed and represents the real-world scenario that the CR will have to encounter in the presence of primary user, PU, devices. Authors characterize the CR system as an interference channel with degraded message sets, ICDMs, since the spectrum sensing nature of the CR may enable its transmitter, TX, to know PU's message provided the PU is in close proximity of the CR. Elegantly using a combination of rate splitting and Gelfand-Pinsker, GP, coding, has given an achievable rate region of the so-called CR channel or ICDMs. Further, in-time sharing is performed between the two extreme cases when either the CR dedicates zero power, highly polite, or full power, highly rude, to its message. A complete review of information theoretic studies can be found in and. This lecture then discusses outer bounds to the individual rates and the conditions under which these bounds become tight for the symmetric Gaussian CR channel in the low interference gain regime. The CR transmitter is assumed to use dirty paper coding while deriving the outer bounds. The capacity of the CR channel in the low interference scenario is known when the CR employs polite approach by devoting some portion of its power to transmit PU's message that will help calculating quality of service for the CR users. Then, we will focus on the scenario when the CR goes for the rude approach, i.e., does not relay PU's message and tries to maximize its own rates only. It will be derived that when both CR and the PU operate in low interference gain regime, then treating interference as additive noise at the PU receiver and doing dirty paper coding at the CR is nearly optimal.